Hello, everyone. Today we're going to do a packet tracer of Cisco version 7, 2.7.1. Packet tracer single area OSPFv2 configuration. This is the addressing table. Objectives: implement a single area OSPFv2 in both point-to-point and broadcast multi-access networks. This is the point-to-point networks, and this is the broadcast multi-access networks. Background: you're helping a network engineer test an OSPF setup by building the network in the lab where you work. You have interconnected the devices and configured the interfaces and have a connectivity within the local LANs. Your job is to complete the OSPF configuration according to the requirements left by the engineer. Use the information provided and the list of requirements to configure the test network. When the task has been successfully completed, all hosts should be able to ping the internet server. Instructions: configure the network to meet the requirements. This is the requirements. Okay, use process ID 10 for OSPF activation on all routers. First, activate OSPF using network statements and inverse masks on the routers in the headquarters network. Here's headquarters network. Second, activate OSPF by configuring the interfaces of the network devices in the data service network where required. Here's the data service network. Let's do the first. Start from P2P1. Enable configure terminal. All right, so activate router OSPF 10. 10 is the process ID. And the network. Okay, let's take a look at the network. P2P1 has 3 networks attached. So need 3 network statements. And an invert mask. Let's go to do some calculation before we continue. We have to figure out the invert mask. Invert mask is also called the wildcard mask. P2P1, 3 networks. Okay, these 3 networks. And the subnet mask is, here's a /30. /30, the subnet mask is 255.255.255.252. The invert mask, in order to get an inverse mask, we need to subtract subnet mask from this number. Subtract the subnet mask from 255.255.255.25. So the inverse mask of /30 is 0.0.0.3. All right, let's do the statements. This is the network address. Let's copy to here. And the inverse mask, 0.0.0.3. All right, area 0, because we're working on the single area. So we use the area 0. Okay, second network is 9. All right. 0.9, so we change. So 9.0.3, okay, residence. Third network is 13. Let's change to the 13. All right. So P2P1, this is P2P1, 3 statements is okay, perfect. So P2P2 has 4 networks attached, so need the 4 network statement. Enable configure terminal router OSPF10 network P2P2, this network. So 10 dot all right, still /30. So mask, inverse mask is 0, 0, 0, 3. Okay. Area 0. This is the first network. Second one is 5. Here's a 5. Okay, let's change to 5. Okay, 5. Okay, third one. Third network. This is a network address. Network address. Okay, 192.168.1.1. Okay, here's a /24. Let's look at the inverse mask. 24/24, the inverse mask is 0.0.0.255. Okay, 0.255 area 0. Okay. Okay, the fourth, the last interface is 2.1. Okay, here's 2.1. 2.1. Okay, good. So P2P2 is okay now. So full network. Okay, good. P2P3 networks. Okay, P2P3. Enable configure terminal. Router OSPF10. Okay. Network has 3 networks. This is first network. All right. So inverse mask 3. Area 0. Okay. The second one is .10. All right. 10, let's change it to 10. All right. So third one is this 192 network. Okay, here's /28. Let's take a look. /28 is 15. 0, 0, 0, 15. 0, 0, 15. Okay, area Okay, so P2, P3 is okay now. So the headquarters network, I think we're down here. Okay, headquarters. So next is activate OSPF by configuring the interfaces of the network devices in the data service network. All right, so we need to configure the OSPF on the interface. So we start from BC1. Enable configures T and the router OSPF10 activated. So let's go to the interface. P2P. There are 3 interfaces. So we need to do BC1 S010. Okay, S010. IP OSPF 10 area 0. All right. Second one is S011. 11. Okay. Yeah. And the third one, G00. 0. Interface G000. Okay. Good. So BC1 is okay now. And BC2 has 2 interfaces. Enable config terminal. OSPF 10. Exit. All right. Interface BC2 is G000 and G001, 2 interfaces. G000 IPOSPF 10 area 0. All right. G001. Same command. Okay, good. So we're down on BC2. And BC3 has 2 interfaces too. Okay. OSPF 10. Okay. Interface BC3 has 2 interfaces, G00 and G001. Okay, G000. OSPF 10 area 0. G001. Okay. Same thing. Okay. BC3 is done. All right. So we finished these first two questions. Third, configure router IDs on the multi-access network routers as follows. BC1 is 6.6.6.6. BC2 is 5.5.5.5. BC3 is 4.4.4.4. This multi-access network. Okay. Let's go to router OSPF 10. Let's go to the router configuration mode and the router ID 6.6.6.6. All right. BC2. Yeah, 10. Router ID 5.5.5.5. Okay. And BC3. router OSPF 10, router ID 4.4.4.4. Good. All right, so we finish the third question. Next one, configure OSPF so that routing updates are not sent into networks where they are not required. This question is about the passive interface. Because the OSPF routing information only need to be sent out interfaces that are connecting to other OSPF-enabled routers. So for the network, the LAN, local LAN network, don't need the routing information. So we need to configure the interface that connect to the local LAN to be the passive interface. By this way, we can save the use of resources and reduce the use of the bandwidth as well. So this is 1, 2, 3, 4, 5. These 5 networks, the 5 interfaces can be configured as passive interface. And also this interface connecting to the internet, we need to configure as passive interface as well. So this can reduce the security risk. So now we have 6 interfaces need to be configured as passive interface. Need to start from BC1. Okay, BC1, let's see, BC1, this interface is connecting to the network. See here, S011. Okay. So here, it's a passive interface. S011. Okay. This is the first one. Then we configure this. So BC2, the network of 192, this one is a local LAN network, BC2, this one. So G000. So passive interface G000. DC3 is this one, G0002. Okay. So we finished this area. This is data service networks. Okay, do this one. P2P2. P2P2 has 2 interfaces that need to be configured as a passive interface. Passive interface. P2P2. Okay, 2 is here. These 2 interface is a local LAN interface. Okay, G000 and G001. G000, G001. Okay, good. P2P2 and the P2P3. P2P3, this is a local one. Passive interface G000. Okay, good. So we finished this 2. Okay. Next, Yeah, that is the network. We finish it. So next is configure router BC1 with the highest OSPF interface priority so that it will always be the designated router of the multi-access network, BC1, with the highest priority. Okay, so the interface is supposed to be this one, the G000. PW1, this one, G000. Okay. Interface G000 type OSPF priority. The highest interface priority is 255. Okay, so we finish this question. Highest priority. Next, configure a default route to the ISP cloud using the exit interface command. So we need to configure the default route on BC1, because BC1 is a border router between the local network and the internet. So we need to configure the default route IP route 0. Okay, exit interface B21 is this one, connected to the internet. So S011. S011. All right, so default route without a gateway, if not a point-to-point interface, may impact performance. But this link is a point-to-point, so we ignore this warning. So this is the default route. This is the exit interface. Next is automatically distribute the default route to all routers in the network. Okay, so first we configure to the default route on BC1. The next we need to, this question is about the propagate the default route to all other routers. So router OSPF 10. Default route, default information. Default information originate. Okay. So, all right. So next is configure the OSPF routers so that the gigabit Ethernet interface cost will be 10 and the fast Ethernet cost will be 100. All right. This question is regarding the interface cost calculation. Before answer this question, let's do some calculation of the cost. So here, there are two calculations. Here's the cost. The both calculation use the same formula, which is cost equals reference bandwidth divided by default bandwidth. They use the same formula, but the result of the cost are different. So let's look at the content of the formula. First, we look at the default bandwidth. Default bandwidth actually is the actual interface bandwidth. These numbers are based on the interface type. So each type of interface has its own default bandwidth. It's constant. So the default bandwidth are the same. So the only reason that causes the cost different is from reference bandwidth. So look at the first formula, use the default reference bandwidth, which is 10 to the 8th power. The second formula uses the adjusted reference bandwidth, which is the 10 to the 10th power. So that is the difference. That is the reason that causes the cost difference. So which reference we need to use to calculate the cost in our question, we need to take a look at the requirements. Here said that configure the OSPF routers so that the gigabit Ethernet interface cost will be 10 and the fast Ethernet cost will be 100. So we need to use this formula. Here's the gigabit 10, fast Ethernet is 100. We need to use the adjusted reference bandwidth. Okay, so but remember that adjusting the reference bandwidth does not actually affect the bandwidth capability on the link. It's only affected the calculation used to determine the metric. So to adjust the reference bandwidth, we need to use the command, the router configuration command of auto cost reference bandwidth followed by the megabyte per second. Let's go, I show you what that means. We need to do this on all the routers. So let's go to start from EC1. We use the command auto cost reference bandwidth 1000. Okay, here 1000 is 1000 megabyte per second. Let's look at here. The calculation, still go to here. So here, so gigabit Ethernet, we need to use this one. So cost is 10, we need to use a 1000 megabyte per second. But here is 1000, okay. And we need to configure this cost on all the routers. Okay, let's bit. Same thing. Here's the BC2. Okay, good. BC3. All right. Okay, and the P2P1, same thing. Enable configure 2 power router OSPF10. Okay, same thing. P2P2. Okay, hold cost. P2P3. Hold cost reference bandwidth 1000. Okay, good. Okay. All right. So we do this. Let's check the cost. I'm just curious. Show IP OSPF interface G000. Here, this interface, the cost is 10. All right, good. All right, so next, configure the OSPF cost value of P2P1 interface serial 011 to 50. Let's go to here. Interface 011. Okay, so IPOS PF cost 50. All right, we did it now. Okay, so this configuration of the cost is a different way as from the previous way. This way is we give the explicit cost number 50 directly to the interface S011. But the previous way is we give the bandwidth to the machine, and the machine will do the cost calculation by itself. But the results are the same, just a different way. This way is through the bandwidth. This is the explicit cost number. Okay, next one. Configure the hello and the dead timer value on the interfaces to connect P2P1 and BC1. P2P1 and BC1, okay, to be twice the default value. Okay, let's do. All right, so let's find out the interface. P2P1, here's 10.0.0.12. 12. So it's supposed to be this interface. And BC1 is 14. Okay, this is S010. Okay, let's do the P2P1 interface S0 to 0. Okay. IPOS PF. Hello interval. Okay, let's look at the hello interval. It's a hello and dead timer value be twice the default value. The default hello interval is 10, so twice is 20. Okay. The IPOS PF dead in interval. So by default, the dead interval is 4 times of hello interval. So you're supposed to be the 80. All right. So we did P2P1, but don't forget, we finished this interface and we need to configure the same timer value on the other end of this link on BC1. Interface is 010. I think it's this one. S010. Okay. So same hello and the dead interval. IP OSPF hello. Sorry. Hello. Interval 20. USPF dead interval 80. All right. So we finished. So here completion is 100%. That means we are successful. All right. So from here, it said after the successfully completed, all hosts should be able to ping the internet server. Okay, here we will not, I will not do this ping, and you can do the ping yourself because we don't spend that time. It's very easy for you. It's very, very easy to do the ping. So we're done. And we're done for this packages of the single area OSPFv2 configuration. Thank you for watching my video. If you like my video and think it's helpful for you, please thumbs up and share with your friends and subscribe my channel. See you next time.